Here we go. So on the first one, you would multiply times 15. After you multiplied times 15 and you worked it all out, I'll give you half a second for the two of y'all to pull out your homeworks so you can follow along and see if you have any questions. Remember that when you have a question, you should ask it right away. I shouldn't have to say that at this point in the year, but here we are. I don't know why I decided to go into announcer voice mode, but it just happened. Eli loves it, don't you?
Yeah, sure do.
Sure, why not? And the crowd goes wild. Do a flip. Okay, so after you choose that you're going to multiply by 15, once you distributed that out and you worked through it all, you would end up with 9y minus 10 equals 6. After you would do that, you would end up adding 10 to both sides and end up with 9y equals 16. Any questions thus far? Is there somebody else we're missing, or am I, losing my mind?
I mean, it's a Monday, so.
Sierra.
Yeah, that's right. We're missing Sierra, but it's Monday, so which is, there it is. Oh, there it is. So I'm kind of losing my mind, but not quite as bad as what I thought. Okay. So, after you do that, you'd end up dividing by 16, and you would end up with y equals 16 ninths. And then after you converted that to a mixed number, you would end up with the number 1 and 7 ninths. Any questions on that problem before we move on?
Mr. Fulkerson, you never told me math was so cool, okay?
I feel like I've told you that more than once.
Okay, yes, but listen. Last night, I discovered the Collatz conjecture.
Oh, good Lord.
And it's so weird. Well, it's not weird. It makes so much sense, but also
There are all kinds of cool math things. Lots and lots of them. Did you know that this is a lot of people know this, but y'all are young enough that you probably haven't even heard of the show, much less the concept that I am going to present to you. There was a show that was made by the same people. You probably have heard of the show The Simpsons, whether you've watched it or not. You probably have heard of it. The same people who made The Simpsons also made another show called Futurama. I'm not a huge fan of The Simpsons. I think it's kind of boring. I don't think it's actually very funny. I think it's highly overrated. I don't understand why it's so popular, but I did like Futurama, even though it's quite crass. Well, I guess it depends on what you're comparing to. You start comparing to Family Guy and all these other things, it's not very crass at all. But anyway, in that TV show, most of the people that worked on that show are like actual physicists and mathematicians, like real science people, nerd people.
Science.
And so there was one episode. In that episode, they actually created an entire brand new mathematical theorem to deal with a problem in the show, which I think is hilarious and kind of awesome. But moving back to our math right now. Because in order to do cool math, you have to do middle school math first.
But like math is cool.
Honestly, there's some cool things in middle school math. I will say that much too. Okay, number 2. We didn't have any. I think I heard a no and then a whole lot of silence and then some other conjecturizing things. So we have any questions on number 1?
1 and 7 ninths is the answer.
It is.
I got 9/16.
Okay, so did you divide backwards on accident right here? That may be what happened. Because that sounds like what happened.
I got my sister to help me, so I think she might have not understood the problem.
So your sister divided that backwards.
Yeah.
Make sure when you're getting help that you're like asking and getting it in your head too. So y'all were almost there, but here at this point you would divide by 9 instead of dividing by 16. So I think that's the mistake. That's the only mistake that happened. And then once you divided by that, you'd have to do long division to get a mixed number. So 9 into 16. 9 goes into 16 how many times? Anybody can answer.
1.
1, yeah, because what's 9 times 2? 18, yeah. So 1, and then we put a 9, and then 16 minus 9 is how many? 7. So that's where the 1 and 7, 9, so that's how that would end up. But yeah, I think you just divided backwards there at that step. Great questions and thoughts and all the good things. So proud. I will even stop before I smack you in the face this time. For those of you listening on YouTube, I am 10 feet away from the children, and I have not ever actually hit anybody in the face. Well, maybe. Probably not on purpose. Actually, I did have a student literally accidentally hit me in the face once. It was quite funny.
How would you accidentally hit someone in the face?
We were going outside to do an experiment. We're about to essentially blow something up outside. It's a great little experiment. We're making a chemical compound that the military actually uses to melt through cars and other things. It's called thermite. It's really fun lab demonstration. So we were all me and this group of kids, and I was walking along, and I just kind of pretended to smack. I didn't hit the kid at all, but I kind of did like this, and it startled her, and she went whap, and I got hit in the face. It was great fun. So exciting.
I love when they were talking with their hands very emphatically.
Yes.
And then, because she's a 2-year-old, she goes, and she fell flat on her face and stood up, and then immediately see mom and went, ah!
Is that why they have thermite grenades?
Yeah, thermite grenades are very scary because they cause a thermite reaction. So not only do they explode, but they melt stuff at about 5,000 degrees Fahrenheit. It's a chemical compound. It's really cool, but we're doing math right now, not chemistry. Okay, so on this one, let's see, what did I do? 7 times 2 is 14. No, 7 times 3 is...
So you're sitting.
What have I done?
This problem is
This problem is uglier than what I intended to do. Let's see.
pretty easy.
So 7 times, what's 7 times 4? 7 times 4 is 28. That doesn't work. 7 times 5 is 35. That doesn't work. 7 times 6 is 42. Does that work? Does 3 and 3 go into 42? 3 does, but I don't know if 4 does. 4 definitely doesn't because 40. Okay, so 7 times 7 is 49. That doesn't work. 7 times 8 is 50. 84 is where we're headed. So, oh, yeah, that's probably what I was thinking when I made it originally, I bet, because I was thinking 12, and those other two were going to 12. Let's jot in our notes in case anybody did this problem and they got stuck in the hamster wheel and were like, okay, I'm gonna just wait. 7 times what equals 84? Okay. And then 4 times what equals 84? You can always, if you're stuck, you remember you can always scratch paper it, right? 4 divided into 84, right? It is 21. So we change that guy to a 3. We can get our last number. 3 times what equals 84? Three goes into 8. How many times? 2 times, so 6, and then we minus, we get a 2. 3 goes into 24, how many times? 8 times, so 28.
I almost said 2 times.
All right, so now we've got all the pieces of the puzzle that we need. I'm gonna, since these numbers are larger, I'm gonna walk this one through with a little bit more steps. I may have to move that other problem down a little bit. We shall see. How we do so far? Are we understanding what we're doing? We haven't really gotten very far on it yet, but we understand what's happening on this problem, or do we have any questions? So, this is number 2. Yes, ma'am. So first thing we want to do is bring down that negative so we don't forget it, right? That's very important. And then 16, machine, times 16 over 4, right? Hello? Times 84. And then minus 28 over 7 times 84, right? We've already figured out what the next part is going to be, so we probably could have skipped to that, but while we're taking our time, we may as well.
Why didn't you write the cake?
Because I forgot the cake. Did you know that I don't even really like cake? Does that make y'all sad? I way prefer pie. Pie is much better than cake, in my humble opinion.
For what it's worth, it's a lot easier to make a gluten-free cake than it is to make a gluten-free pie.
No, that's not true at all. There's like 50 bazillion options for gluten-free crusts.
I mean, I'm aware of that, but it's...
I've even made both.
I know.
And the fillings are almost always gluten-free, so gluten-free pie is way easier to make. I think your entire premise is a lie. Okay, so we already jotted down what these are going to be, right? When we cancel it out, so it's going to be a 1, and this one is going to be a 21, right? 4 does go into 16. Oh, yeah, it does. So you could reduce it that direction. Sure. Either way. You should get the same answer either way. That's true. You couldn't do both, because once you've reduced the 4, it's now a 1. So if you reduce it this direction, then this isn't a 4 anymore. It's a 1 now. So if you reduce it that way, it would be, I'll do a different color. It would be 1, and this would be a 4. And that would still be an 84. That's absolutely a way that you could do it, and you'll actually get the same answer if you do it that way. But you couldn't make the 4 double duty. It would have to be a 16 on the bottom. And then it would receive more because it would be 1 and 1. Right? Okay, so this one we already know is going to be 1 and 12, right? This one we know is going to be 1 and 28. And we know that, in case you're like, wait, how do we know that? It's because we know that because we already figured those out over here.
May I go to the bathroom? I gotta wait this time.
You did great. I'm so proud. Yes, sir, you may. Okay. So we need to do 21 times 16. Right?
Yeah.
That's definitely one we want to scratch paper. There are some tricks to doing that in your head, but we're not learning those today. Or probably ever in this class. 6 times 1 is 6. 6 times 2 is 12. Bring a 0. 1 times 1 is 1. 1 times 2 is 2. Add them up and we get negative 336. Sorry for that ugly 3. He kind of died a painful death, but it'll be okay. Because he kind of turned into a 7, so maybe he's happy over there. No, that is lies. This 3 died. He just straight up died. Most of my 3s basically sort of look like 3s. They just look like fast 3s. That guy, he didn't survive the process.
Yeah, I don't really know what you were doing with any of that memory, so it's not...
Yeah, but I said it out loud and we wrote it better over here. So
Yeah, redemption.
that's the one that matters, right? Because that was just scratch papery, right? So then we got to do 28 times 12. I'm going to bring down the negative right now before I forget. How does that sound? Great? Good. Watch your negatives. I've said this before. I'll say it again, probably till you graduate from high school. Maybe I'll come to your college graduation and tell you, did you watch your negatives?
Well,
That would be funny. Maybe I will shout it at you from the seats in the stadium wherever you graduate from. So 28 times 12. We got 16. 2 times 2 is 4 plus 1 is 5. Scratch and 0. 1 times 8 is 8. 1 times 2 is 2. We add it all up. We get a 6. We get a 1. We get 13. And a 3. What happened? Same number. How did that happen? Did I do something wrong or did it just happen? Cool. Okay. So we all got it wrong. Or maybe we all got it right.
I wrote 320 minus 336. What? Equals birthday cake.
No, times birthday cake, right?
No, I just. Well,
Birthday cake equals 6 times 28.
so 28.
6 times 2 is 120, or 6 on 20 is 120, plus 8 times 6 is, yeah, we could do this. Here we go. 28 times 6. What's 6 times 8? What is 6 times? Quit worrying about my cool, fast 6 and tell me what 6 times 8 is. 48. That sounds great. He rhymed. 6 times 2 is 12, plus 4 is 16, 168. Let's grab a marquee and go wha-bam. And then let's grab a little move and go wha-bam. Stop it.
I was so threatening. It's like, hey, you're gonna stop it or I'll stab your eyeballs.
Look, they're scared.
Whoa.
They got scared. They got terrified.
They got
Terrified. And then what would we do? Since we're taking our time on this one, we may as well do it like it's an example. So what would we do next? Stop it.
They were scared of the weird 6.
I need this to come back. I need my brush and stop it. I don't want you to tell me things. I know what the brush tool is. Why do you keep telling me that? Why are you?
I'm so sorry.
I don't need all this hand holding. Fruit tracts.
What?
Yeah, it's a cool way of saying true facts. You gotta be cool like me to understand. Look, all of those look like 3s, and that one even looks like a 6. What now, Eli? Fight me. Okay, that times what is clearly a birthday cake. No denying that fact. Plus, so let's scratch paper this guy. 336 plus 168. What's 8 plus 6? What's 8 plus 6? Oh my gosh, you don't have to sound so depressed about it. Calm down.
You're telling us to calm down?
What'd you say, girl? Oh, look at that. Good catch. I forgot to bring a negative down, which is going to totally change what we're doing here because this isn't this anymore, is it? It's that one. Good catch, girl. I'd like to say that I did that on purpose, but this time I did not. It just happened.
Say good catch, bro.
No.
Good catch, bro.
No. I would not say such a stupid thing as that.
Oh, wow. I didn't know the surfer dudes are.
No, they're too chill. Quite witty. What do we have to do now in order to subtract 8 from 6? Borrow the evilness of the borrowing. Turn that into a 2 and this into a 16. So it's 16 minus 8. Um, Stop it, guys. What is 16 minus 8? You can make the noise, but you have to actually think about the math too.
It's 8.
It is 8. That is true. It's absolutely true.
Negative.
No, if it was 8 minus 16, it would be negative. But it's positive because it's 16 minus 8. Are you actually confused or are you just enjoying your face? It's 16 minus 8, yes?
I thought it was 8 minus 16 because you're taking 8.
Well, the 8's on the bottom, right? And so it's 16 minus 8. You're taking away 8 from the 16. That click? Good. You're doing great today. Very proud. Your questions are on point.
Ow, my head.
No, you're lying.
Ow, my face. Oh no.
Okay. So, what do we have to do now?
Subtract.
Right? So, 2 minus 6. Can't do it. What do we got to do now? Borrow from the 3. So, oops. No, I decided to wait so that I can give it back when Sierra's here. That way we all get them back the same day. So what's 12 minus 6?
But you have them ready.
Maybe. I'm not giving it back to you till Wednesday. Are you stressed about it? Don't be. It's going to be okay. What's 12 minus 6?
6.
And then 2 minus 1?
1.
1. So we have negative 336 cake equals 168.
Then you would divide 36.
Yes and yes. So we're going to divide.
Wait, wouldn't it make the number smaller if you reduced it first?
Wait, well, there's nothing to reduce yet.
I know, but when you're done,
Yeah, absolutely. Not only are we going to reduce it first, we're going to reduce it only. Because that's all we have to do to finish this one out. Because the smaller number's on top. So it's not going to be a mixed number. So yeah, so what we have now, we're kind of running, I'll leave a space for my answer and then we'll scratch paper it out over here. Because I bet because the numbers are large enough that it's going to take us a couple steps to reduce it all the way. I'm guessing, but I could be wrong. It's actually, if we get the more number sense that we get, the more you could look at this problem and already tell what this is going to reduce to. But that's okay, because I don't think we're quite to where we're going to see that, obviously, yet. Okay, so what are we going to reduce this by? And let's go with what you said, probably. It's even, right? So what are we going to divide by? 2.
I was going to say 70.
I don't think 70 will go in there. It's worth trying. What? What's 168 divided by 2? Do it on your scratch paper, kiddos, if you need it. Y'all should have pencil in hand, or at least pen.
84.
It is 84. 84. And then give me 336 divided by 2. Scratch paper it. If you're sitting there and you don't have the answer, do not try to do that in your head. Stop it right now.
168.
Somebody else verify for me. Okay, verified. Okay. What do y'all wanted to reduce these by? You might be able to see something, you could do 2 for sure, right? They're even. But you might be able to see something at least a little bigger on these. Do y'all see anything a little bigger that you could reduce by? I don't think 7's going to work. 12 might. Try it. See what happens. Scratch paper both of them. Y'all do it. 12 into 84 and 12 into, I don't know what I'm writing. 12 into 168. Y'all scratch paper that and see if that works. If it does, we'll go with that. I know we don't all have our 12s memorized real well, so take the time. Take the time to do it. And work on your 12s. Work on all your multiplication facts. If you don't have them pretty well in hand, it'll make your life easier. True facts. Okay, good. So that one works. So try the other one. 12 into 168, which might actually, in a silly way, be easier than the other division problem. Truthfully, because 12 goes into 16 is pretty easy. Because how many times would that be? Once. So do that. And then subtract. And then see where you go from there. It does go in 14 times. So those both work. So yeah, let's divide it by 12, which we have already done the work for. So we're going to write the answer. So we're going to write a 7. And it is 1/2, which means 7 would have worked. Whoever kept saying 7, you and you, I think both of y'all said 7. You were right. So then we're going to divide top and bottom by 7, and you end up with 1/2. And so our answer is negative 1/2, right? Now let's talk about this from a number sense standpoint. I need everybody paying attention. Is everybody paying attention? Okay, I'm going to take the stunned silence as a hopefully. What did we determine that 336 divided by, it's not divided by, minus 168 is? 168. You see how these are the same thing? Which means that this number is half of that number. So we could have gone straight and divided by 168 and got all the way to the answer.
Why didn't we do that if it was...
Did you see that we could do that without me telling you? Did you really? I mean, maybe you may. I'm not saying you couldn't have. Y'all are all quite clever humans in here. You felt like it, yeah. But it took me walking you through it. Okay, so the reason why we went and did it this way is because right now in your math career, most of you or all of you, I don't know, are more likely to not see that immediately. And so we need to make sure we can do it this way in case you don't see something like that. But as we do things like that, it's going to be more and more helpful, and you're going to get better and better at math if you start to add some of these ideas into your brain, which is why I took a minute to point it out. Does that kind of make sense and answer your question? All right, let's look at number 3.
How many columns did we have?
You've got the homework right in front of you. You should be able to tell me. All right, so this one, we should have stuck an 18 out here, right? This one's easy compared to that last one, so we're going to be back to kind of fast mode, right? So when you did that and you distributed it all out, and you did all the things, you should have ended up with 4 minus 4L equals 18. The answer to that question is the same as the answer that I gave you the last time you said the same statement. I am not doing the homework right now. I am making a key with you so that you can check along with it. And I have more experience and can do things better in my head than you can. True facts. Now, the reason I tell you not to do things in your head is because you'll make less mistakes. True facts. And that's a fact. That's true. When I actually make the keys, I do less stuff. I do less things in my head than most of you do. I write down everything because I don't want to have to remake my keys.
What if you have to do 2 + 2?
That I can probably do. Okay, so after you did that, you would have subtracted the 4, and you ended up with negative. Are we focused? Are we paying attention? Are we looking at your problem and my problem, making sure that your steps match? I hope the answer is yes.
I got 4 - 4L equals.
Okay, negative 4L you would have ended up with negative 4L equals 14, right?
I got 16.
So we would have done 18 minus 4. What's 8 minus 4? It's definitely not 6, buddy. Look, think about it this way. What's 4 plus 4? 8. So that's 8 minus 4. 4. So we get 14. Okay. Then you would have divided the negative 4, and you would have ended up with L equals 14 over negative 4, right? If you thought like what Ella was pointing out on the last problem, you might have pre-reduced, you might have not, and reduced those both by, I was almost about to tell you a lie, reduce it by 2, and ended up with negative 7/2. You might not have done that, and that's okay. You might have just gone straight to divide. We don't like the bigger number on the top. We don't, right now at this point in your math career, we don't like improper fractions. Later, when you get to Algebra 1, I'll tell you to leave it as an improper fraction. But for now, we don't like them. Actually, that actually depends on context. But we don't like them, so what would we do next?
Change it to a mixed number.
Yeah, so we divide it, right? 2 goes into 7 how many times? And you would end up with L equals negative 3.5. Any questions on this problem? Okay. Last problem. I'm going to erase some of this mess from number 2. Last problem, you would have taken it and you would have stuck 35 on the outside. Right?
No. I wouldn't do that. I forgot that stuff. But I still got 35.
What? You still multiplied by 35? Okay. That's, yeah. So once you did that, you would have ended up with 14 minus 5 equals 6p.
But instead of brackets, could you do parentheses and it would mean the same thing?
Yes, ma'am, it would. It absolutely would. And you could, yeah, and that'd be fine either way. So the next thing you would have done is done 14 minus 5 and ended up with 9 equals 6p. Then you would have divided the 6 off and you would have ended up with p equals 9/6. And then you would have killed the improper fraction, turned it to a mixed number, and you would have ended up with p equals 1 and 1/3. Half. LOL JK. That's what I said.
I got 1 and 3. I got 1 and 3/11.
Where did it break? Did you get this step or did this step or this step? When did Did you get this first line right here or no?
I, for some reason, wrote, like I did, and I got, so I can have to do that for about 14.
Good.
And I got all the rest of the stuff, and then I wrote,
So you did get this line correct.
yeah.
Okay.
I wrote +5 on each side, and that's where I got 11 from.
Okay. So let's stop and look at that. That's I understand your mistake. Let me show you why you can't do that. Okay. Equals 6p. So you could add 5 to both sides, but not the way you did it. Okay. So you could do +5 and +5. Now, these would cancel, right? And you would get 14 equals, and I'm going to rewrite this all out just sideways. 6p, whoops. I accidentally clicked the erase button. +5, right? We cannot combine these together into 11. Whoops. Why can we not do that? Why can't we turn that into 11p? What's wrong with that? Sure.
Because the P is with the 6.
Yeah, because this 6 has a p on it, but the 5 doesn't. He's lonely. Because I was highlighting it. Okay, so you can't combine. So it wouldn't. So if you added p, so if you did add 5 to both sides, that's a way to solve the problem. Now we kind of talked about this last time, but that's okay. If you did that, we're trying to get p by itself, right? So what would we have to do next? Okay. If we divide the 6, this is not what I'm going to recommend, but I'm going to show you what would happen if we divided the 6 next. If we divide it, we've got to divide everything by the 6. So now after we took all that time to get rid of fractions, we put them back in. Okay? So instead of dividing the 6, what could we do? Yes, we could. That's not what I was thinking we were going with, but that sounds fine too. Sure. So minus the 14. Now the 14 would go with which one on this side? Would it go with this one, with this one right here, or would it go with this one over here? The 6 one or the 5 one? The 5 one. That's right. How do you know it goes with the 5 one? That's right, because they both don't have p's on them. So this cancels. What's 14 minus 14? 0. So we'd have 0 here equals 6p. And then 5 minus 14 is going to be negative, right? Because the bigger number is negative for adding and subtracting. So we've got to do 14 minus 5 real quick. What's 14 minus 5? It's not 11. Definitely not 11. The way I think about these, and I don't know if this will help. It helps some people and doesn't help others. So the way I think about it is I think about, like, I kind of turned it into an addition problem in my head. To get from 14 back to 10, how many do I have to go? What's the difference between 10 and 14? How many numbers on a number line would I have to go here? 4, that's right. So I have to go 4 to get here. How many do I have to get from 5 to 10? So what's 5 plus 4? 9, which is easier to do in your head than subtraction. So that's what I do in my head to do those subtractions when it's around the 10. I see what kind of difference it is, and then I add those. That's what I do. That's what I actually do in my brain when I'm doing those. That works for some folks and doesn't for others.
I do how many times? Just what? I only do like 5 plus 1.
Sure, that's fine. Okay, so we're still trying to get p by itself. What do we got to do now?
Divide 6.
We're going to end up with fractions again if we divide first. Remember, it's usually easier to do addition subtraction first, right? So what could we do if we were doing the addition subtraction first? Plus 9. So those cancel, right? What's 0 plus 9? Now what do we got to do? Divide the 6. So we get p equals 6/9, or excuse me, 9/6. And then 6 in that goes into 9, how many times? So what's 6 times 3? 18. So 6 goes into 9, how many times? What's 9 minus 6? It is 3. 1 and 3/6. What goes into 3 and 6? So you get the same answer that way. So you could have done that and gotten the answer if you added 5. You just wouldn't be able to add it to the same place. Now, I'm going to recommend that the thing about doing it this way is on these things, you should look for if there's an obvious easy thing. And if you just have 14 minus 5, why not just do 14 minus 5 to begin with? Because it's so much easier to clean up as you go. Does that make sense to everyone? Any questions about any of those homework problems?
So is the answer 3 and a half?
1.5. What'd you say, girl? I mean, if there's something that you can clean up on one side without even moving anything over, do that. Like this is a cleanup thing. We clean that up, simplify it, because 9 is simpler than 14 minus 5. Mm-hmm. Did you get your question answered, Ella? Okay. Oh, okay. Gotcha. Okay. Whose turn was it?
So it would have been Sierra's. She's not here.
Okay.
So
All right, Gina. We don't have 72 in it yet. Quit crying. You know you want to get all the way to a 72. You know you do. Don't even lie. We're going to finish this problem and you're going to like it.
I thought you couldn't finish the problem.
We know when it's going to end because we already determined.
But if people keep on picking big numbers, it might never get.
I bet it will.
so
How much you want to bet? Okay, Gina, what are we going to add, subtract, multiply, or divide to this thing that we have created?
multiply 658.
Oh, why?
So at this point, I know we played with the distributed property last time, but we're going to actually kind of do this the easy way and not distribute it because we're going to make our life a little bit easier. How's that sound? Okay, so we're going to multiply by, oh, I have to be in the right layer. There we go. Multiply by 658. Multiply that side times 658 and multiply this time side by 658. Right? And then I'm just going to rewrite that thing. Y'all want parentheses or brackets or something else? She just said it. That's where we got it. This is... You don't remember writing like the... Before I just put the 658? Or... For 11 over 12 plus 11x over 60 minus e equals 12, 0, 0, 0, 121 over 120 minus e times 658. All right, Asher. The pièce de résistance. What are we going to do with the 72 we all know you're going to add to this problem?
Subtract 71.
Oh, no! He broke it! It's all broken and ruined! Eli's life is so ruined!
How could you?
Okay.
How could you?
That's very, I approve, Asher. Very, very good trolling. I am so proud.
I'm ashamed.
You're the worst, Ashley.
Oh, I was looking forward to doing that for like since last class.
Very good.
I was planning on doing that the whole time.
I believe you. You had an idea and you kept it. Okay. We made a really ugly problem.
Aren't you just writing the same thing over and over?
Oh, oops. I forgot the minus 71.
What about Sierra?
Oh, sure.
Times it. What I think we should do is we should put a pin in this problem. We should wait till Sierra's here and let her add her thing and then solve it next time. And then in the last few minutes we'll add some homework problems. Actually, you know what we might do is, because am I scrolled up enough?
Yeah.
We might actually start playing with proportions. Because I think we're getting the topic that we've been doing for the most part. So we may actually start moving to the next thing and then not have homework on this Monday.
Whoa!
Yeah, we'll have to do it on Wednesday morning.
Y'all didn't know. Did I leave? Was that supposed to be a 12? Has that been a 12 all? It's been a 12 all along. Okay, great. Great.
It was 12.
So, yeah, next class, we will let Sierra add something, and then we'll turn all of that
Maybe she'll add the
back
72.
into x equals 5.
Maybe she'll add the 72.
Y'all think we can do it?
I don't think so.
You don't think so?
But I'm a changed man.
Oh,
now.
I forgot something rather important. And if I don't add it, then we won't be able to get back to x minus 5 or x equals 5. So,
You just write that over and over again.
girl, I didn't. I added something every time. Every single time I added something. And by I added something, I mean y'all sinister humans added something. Okay.
And Asher ruined our lives.
Asher trolled every one of you, and it was beautiful. I loved it.
Well, you learn from the best.
I don't know who that was.
Him.
Okay.
No, you.
What we're going to do with the last few minutes is we're going to start our next lesson.
No!
Thought we'd get right off the hook. You got it.
Everybody get this copied where it needs to be? Can I kill it?
No.
Okay. Get it down.
Murder it with an axe.
Like an axe murderer?
Like me.
I'm going to kill it by poking out its eyeball.
I don't think it has an eyeball.
Draw an eyeball.
It does, actually. It's right there.
Where?
Right
Oh,
there.
It's right there it is. Where? Wow. I forgot the original.
True facts.
Where? On the side.
Finish copying. We're waiting on you.
I'm done.
If we have to wait much longer, I'm going to give y'all homework.
I'm a man of 71 now.
You traitor to the cause.
73.
It'd be better if you were 71 and...
You just actually burst
oh, no, that's right. You're all right. Just kidding. LOL. Okay. You can copy from your neighbor if you're not finished. Okay. We are going to start... Perfect timing. We are going to start talking about solving proportions. And we will probably camp out, other than maybe a few more fun problems, like just for fun problems. Other than that, we're probably going to camp out in proportions and proportional reasoning for the rest of the semester, probably. We'll throw in a little bit of geometry and a little bit of
Hideous noise with your face hole.
word problems and all kinds of things that are fun.
My face hole.
Okay.
I have multiple.
Your eyeballs.
Before we start this, I like to scream about something just a little bit.
Oh, yay.
Because I have found repeatedly over and over and over and over again that once we really start talking about proportions, people forget how to multiply fractions, just like multiplying fractions. And so I'm going to scream that you should not forget how to multiply fractions. And so to remind ourselves how to multiply fractions, how do you multiply 3/4 times 1/2?
By adding it.
Quit lying. How do you multiply fractions? What's the answer to this problem? Straight across. Thank you very much. So as we learn proportions, because we're going to learn something with proportions that's going to stick in your brain, because it always does, I know. Don't forget then when you multiply fractions, you do it straight across. 3 times 1 is 3, 4 times 2 is 8. The answer to this little problem is 3/8. Don't forget how to multiply fractions. You think we can handle it? I do too. So, a proportion is something that looks like this. We're going to write one that doesn't need to be solved. We're just going to write down an example to begin with. So, this is a proportion. 5/6 equals 30/36.
But
That's a proportion. Make sense so far? What's 5 times 6? What's 6 times 6? 36. So does it make sense that 5/6 equals 36? Yes or no?
That makes sense.
The fact that those two fractions are the same fraction doesn't make sense? You should have been seeing this since like the 3rd grade.
Oh, I get it now. Yeah.
It also equals 10/12, right?
What? Oh.
How did I get there? I multiplied them by 2. That's all I'm doing. Multiplying by a constant. Basically, I am unreducing a fraction.
So they're pretty easy.
Yeah. What's something else we could write this equals? Pick something, multiply it. Somebody give me an example. We're not going to get out. It's already 11:16. We're not leaving until we write 2 more of these. Stop it right now. What? 2024 sounds great. You multiplied by 4. Sounds great. So I want one more, and it cannot come from Olive because she already gave us one.
71 over 72.
Dude, you have to multiply the numbers. Quit saying random things. We're already over time. 15/18. You multiplied by 3. Sounds great. When we come back next time, after, well, actually, probably won't be next time because it probably will take all classes to undo the other mess that we made. But once we get back to this topic, which will either be next time or the time after that, we'll solve a problem like this. And we'll solve for x. Okay? Goodbye.